Hello, everyone. I'm simply struggling right now with Zoom because at some point I was struggling that people were coming straight without a waiting room. And of course, what happens now? I need to let everyone single-handedly in. Okay, I think now everyone should join, should be able to join straight away. Not 100% sure about that. Oh my God, Zoom can be hard. Is anyone complaining in Slack that they can't join or so? Do we have anyone more?
I was able to join pretty easily.
Yeah, we are getting more. Awesome. Now I just need to switch off the member and close Slack. And now, second check. We are recording. Perfect. Because this is the second reason why I'm doing this. I hate talking to myself on a Zoom recording. So I wanted to do this in a session so we can record and save this for later and put this on YouTube for other team members who don't have time. Thanks everyone for joining. Thanks for joining for the first time the performance session. Why did I choose the funky name session? Because I really want to be have this as a hands-on thing from here on. So this means really we will most probably start at, especially at the beginning in the first sessions, with a lot of knowledge sharing and a lot of introduction to all the things that we have already at GitLab, because I call this secret and hidden knowledge, which is there are people who have something which they use every time 20 times a day, but no one else has a clue about it because it's somewhere hidden in the handbook or it's somewhere hidden somewhere else. So this is why I want to give some sessions, first by myself, but in the next weeks also around the performance bar, about log files, about other tools that we are using, measuring with the Chrome Dev tool. So really all those introductions, we get them to video, and then hopefully we basically convert more and more over time to be rather hands-on and be rather discussing around bigger initiatives and how we are doing there, if someone has seen something that we can do, etc. But really get started from here on. So if you have questions, put them in the agenda, put them in chat. I will try to answer them right away during the session so that I'm not going somewhere and not everyone is able to follow because I'm already way down in the topic. So let's get started. Where are we at GitLab with application performance? I would say we had always a little bit an eye on it, but we never had a focus on it. What we really wanted to do, especially in the this quarter and last quarter of our fiscal year, is have way more focus on improving that performance and really working on it, really investing into it, really taking it from the ground up. And that's exactly where we are. We are at the stage that we have an open source solution, which has grown over time, which has, especially in the front end, has collected a lot of, I wouldn't call it technical debt, but really like debt that we are carrying around of things that we need to sort out, that needs to be sorted out, that have been decided before there was even a front-end engineer at GitLab. So that's what we are trying to clean out. We are really at the beginning of it. I always say that performance improvements is somewhere between like Formula One tuning, where you measure, where you just do small changes here or there, or it's like pulling something with a tractor out of the mud. I would say we are rather on the side of pulling something out of the mud with the tractor. But over time, and what we have also seen, especially over the last couple of months, is we are improving steadily and we are improving and the numbers are decreasing. And I really foresee that at the moment, we are 100% focused in reality on loading performance, that we are really making a curve over time, so that as soon as we have loading performance figured out and have really improved that part, that we are getting more and more into the area of really like interaction performance, performance of things that load afterwards, really complex performance optimizations. A huge topic is, for example, PWAs, which is something that is rather in the area of mobile, but you can do by now the same thing on desktop, which is really around having service workers that cache stuff in the background, that you have stuff that is even just diff caching, etc. So there is a lot of complex stuff in the future. Right now, we are more in the basics. What we have done and what we have aligned with, and that is really the first topic, is the intro to Web Vitals, is that we have aligned way more to more standards that came around in the last 12 months, I would say. We were first and foremost, we were focused a lot on speed index, which is a little bit of an older measurement, a little bit more of a complex measurement, as it was measuring different packages and mainly based on a video, and of course that can also have different impacts. So what we have done in this quarter is really we have moved over and we are focusing now on something which is called the largest contentful paint, which is one of the Web Vitals as they are defined also by Google in the link on the top, which is they define 3 different Web Vitals. One of them is the largest contentful paint. The other, which is really a very basic thing, which simply says, okay, what is the biggest element on the page and when was it painted? And that is basically the marker for when the LCP is set by the browser and the LCP is measured. They also define on top of that something which is a little bit below, which is the cumulative layout shift, which is simply how much does the page still move around after it has been loaded. Because this is especially has a high impact on perceived performance, which really means that as long as everything is jumping around, you never have the feeling that something is really fast. And the third one is the first input delay, which is really around how fast can you interact with the whole page. So for example, how fast can you, in a new issue page, go in and click and type something, and basically measuring those 3 main things. What we are focusing on, and that's going back on where we are currently in this phase of performance improvement and measurement, is really that we are focusing on loading performance. We are focusing on this largest contentful paint, because we need to start somewhere, and it's the most and generalized number that gives us a good insight on the combination between front-end and back-end. On top of that, to have a better measurement and separation, we are also very focused, of course, to time to first byte, which is simply how long did the backend take to render something to the browser, like the first HTML, and that we have a better understanding, is it rather in the backend or in the front end, and have exactly set those goals. To get started with my screen sharing, I will show you also that you have a better understanding, which is, for example, the project homepage. And if you do there in the Chrome DevTools, you do a measurement, which it's called in the Performance tab. And there you have now a marker, which is this LCP, the largest contentful paint. And if you go down here, you see the related node. So this is really, the browser is looking at everything that comes to the screen, and at some point it will say, okay, the biggest element on screen is this diff.committer, and this was basically on screen and didn't change anymore at a timestamp of 1.2 seconds. And that's what we are focusing on. And this is, of course, a combination of everything that is on the backend side, everything that is on the front end side during the initial loading. Good. The other thing is that there is a huge difference how you can measure, of course. You can measure with different settings on the connection. You can measure different settings on the CPU. There's a huge trend, especially around websites, to measure rather mobile-based, which is like you measure everything mobile up so that it loads really super fast on mobile, which is not really our first and foremost target at the moment. So something that we are still doing is we are measuring everything with a cold cache. So this means nothing is pre-cached. This is like any user that hits exactly that URL for the first time, goes in, sees it, and that's it. We are most probably converting this in the next quarter so the quality team, for example, is already measuring with a hot cache. So they have an initialized cache, which makes the situation and the measurement simply a little bit more realistic. Why is this important? Because at some point, or to some extent, we are already getting in the area where we would rather optimize for the statistics, but not the real user experience. So we are already measuring in comparison the 5 most used routes also with a hot cache, so that we have a better understanding. Are we just improving to get better statistics, or are we really improving also on the user experience side? And the same goes, of course, also for all the best trends and best practices and all that stuff. They are not always applicable, as we are rather a web application than a website. And to get a better understanding where we are and what basically our numbers are and where the split is happening at the moment is, for example, a very fast page on the backend side is the issue list. We have there a 563 millisecond time to first byte, which is what we recorded today in the morning. And until we have this first contentful pane, so the thing that I just showed you before, it takes on our measurement instance, which is a GCP instance with a little bit of a lower CPU, it takes until 1.7 seconds. This means in reality that we have 1.1 seconds of global front-end initialization at the moment, which is important because this is exactly this huge pile of legacy stuff that we are currently trying to reduce, which is a huge bunch of a big pile of CSS and a big pile of JavaScript that already got reduced by a lot. So the biggest thing that we are currently working on is really reducing this mountain of CSS with excluding everything that we have on this page-specific focus that we just loaded on that page, that we get rid of old classes, that we get rid of really bad things that are happening there. But there is our biggest focus. We are still loading, I think, 1.3 megabytes of basically optimized CSS already, which is way too large. And there is currently our biggest target. This is bad in the sense of that we have way too much, but it's good in the sense of those are still low-hanging fruits. This is nothing that we are trying to squeeze 100 milliseconds out of it with an effort of a couple of months, which at some point we will get to that, but right now we have easier targets. And the good thing also about it is everything that we improve there and every investment that we make to reduce even by one line means that we have a global improvement in the end. So everything that we are now at the moment able to reduce that CSS size, and we have also, for example, reduced the JavaScript already a lot, is having a direct impact on all of those pages. Good. Part 1, any questions? Nope. Good. Then let's jump right into one thing that I have seen way too much over the last weeks is all our site speed measurements. What is site speed? Site speed is a collection of a couple of tools that are put together to measure really in real world the performance data. It's also collecting from some other data sources. So one, for example, is the so-called Chrome user experience report. We are able to pull in data from there, which is when people browse with Chrome and they have everything activated of data sharing, they basically also share the performance of that page that they are currently looking at with Google, and they store it in huge big data, and we can query that so that we can see how are people doing in Singapore with GitLab, how fast is it for them, and how fast is it on average, and all that topics, which is one thing. But the main thing is that we have Sitespeed running. It's a Docker container. It's running around every 3 to 4 hours at the moment. We have a list of URLs that Joshua has collected, especially from product, which is all the URLs that we are currently monitoring not logged in. And there's also another TXT file that is basically defining all the URLs that we are able even to measure with a logged in user. So we have a special user and just give us a ping in the research performance channel that we can help you with, that can also test stuff that you can only see if you're logged in. You can of course also see something here, which is the official name of the URL in our monitoring, and you can see those names a lot in the different dashboards. And at some point, if you are not, if you don't directly see which page this in reality is, you can either look it up here, or you can go into a detailed report and see which URL was directly monitored. And the other thing is, if you have a route that is not covered yet, if you have anything in your area that you want to have measured, just add it, create an MR, we merge it, and off we go. In the next run, we basically get the data also included in there. So that's the setup. We are running a set on a Google Cloud instance in the US. I think it's even the same region as a lot of our servers at the moment, which means that the global thing is not too big. We limit the data connection to cable. It's not a very strong machine, so it's also a little bit limited in their CPU, which is good. It's not like mobile, but it's somewhere in between. And this is basically piping recordings every 3 to 4 hours to our dashboards. And if you take a look at the dashboards, and we have a couple of them, you already see quite a lot. Luckily, Sitespeed has just updated them recently, so it's much easier and much clearer to see what are good things and what are bad things. So that already helps a lot. So as you can see, our JavaScript is still too big, our CSS is still too big. It's reducing, but still we need to crunch this down and get this lower. The other thing is that you can see directly here is the so-called LCP that we are measuring as we getting this in. So you can also limit the graphs to it. And the other thing is we are collecting a lot of data, especially these are our engineer dashboards, and they help and they can help you a lot. So there are tons of other data. You can find all the definitions of it in the Sitespeed reports, and they can be very important on figuring out especially problems, or most of the time currently we are not figuring out problems, but rather figuring out low-hanging fruits that we can change to improve overall. As for example, in the last quarter, one of the biggest things and one of the biggest targets was definitely the change of the first pane, so that getting something on the screen faster. And for example, let's see, last 30 days, I think it ran already out. If we put this to last 90 days, then you can see clearly, you can even better see it on the Explore page, which is one of my most favorite ones to measure to some extent, because it doesn't include too much. So it's much clearer, especially for the front-end renderings, to see what's going on. So what we see here, for example, was the huge drop that we made some time ago. When was it? Beginning of August, when we first activated Startup CSS, where we were able to drop really the time until something was painted on screen by almost half, or sometimes even more. And that's what I mean with, it's not about one number, it's always on the overall user experience, but we have a clear focus right now on LCP and to get this improved. What else do you have? You have, as said, up here, you have something more interesting, which is the desktop cached. That's what I meant before with that we are also running all measurements with a cached server service, so that basically we visit another URL, the Explore URL, before we actually hit the URL that we want to measure. I will turn this now again to 30 days. We are even monitoring a couple of different domains. So we are on the desktop cache, not, but on the desktop, we are also monitoring the website dev. So if you want to test something directly on dev, also easily possible. Then on page, you have the different pages. As said, the connectivity, we have only cable at the moment, as we otherwise would need to run even way more runs. And as we are very focused only on cable, only on desktop, this means that it's much easier. What else do we have here? You have at the bottom also something quite interesting, which is exactly what we are currently trying to reduce, and which is the CSS size. And as you can see, we are able to reduce this from time. So over time, so we started with 1.7 megabytes content-wise, and we are by now at 1.3 megabytes, but I still believe we can go way below 1 megabyte if we are doing this right and with the right things. Then we have on top of that a lot of more dashboards. Page timing metrics gives you especially more insights around stuff like CPU, the speed index, which was our former thing, fully loaded, which is basically happening after LCP. So yeah, you can get a lot of statistics in here, and simply take your time, especially as you're researching something, to really take a deep look at it and discover the different things that you see. The even bigger thing around here is that you can see runs, and I will now limit this to 7 days because otherwise my machine will go crashing if I'm doing Zoom at the same time, which is this little checkbox, which is a huge help. And if you click on runs, then you have suddenly some markers, and you can open each individual run data, and you can see all the data that is included there, everything that happened in there. You can take a look at anything that Sitespeed has recorded, which is, I think, 200 data points and a lot of information. So one of the things that you have here is that we are always doing 2 runs. We are taking a median so that we have a better understanding, and we have still a lot of going way above the scale, so which is also interesting because then you can research what happened exactly there. As said, lots of data. You have also the possibility to take a look at the waterfall. There you can see when basically the backend came in with the time to first byte, which was in this case at 668 milliseconds. And then the whole waterfall of the front end happened until we hit around here the largest contentful paint at 3.4 seconds on the issue detail page. And what else do we have? The metrics, which is also something really interesting because you have a couple of different data, starting from the LCP to how complete the whole page is, how ready the whole thing is. So depending on your use case, there might be even numbers that are way more important than our fully official LCP ones. You have the video, and this, for example, is a pretty interesting one. It's not looking funky, but it's also can give really insights because you can slow it down and you see each of the individual things when they are loading, how long they took to load, and that's a great tool, and that's something practically that I will show at the end. How we, for example, figured out what is going on with the issue detail page and how we improved the LCP there.
Sorry to interrupt. Quick question. I noticed it's not logged in because the performance is different between users that are logged in and not. Do we have metrics for?
No, I think we are measuring completely different URLs with logged in and non-logged in. The thing with the logged in is also that we have only test projects, as we wanted to have one specific user that basically just has test data in there. So if anything happens to the monitoring, etc., with that login data, it's just contained. But we are not measuring at the moment between logged in or non-logged in. Did this answer your question?
Yeah, thanks. Yeah, I'd like to see that in logged in because, like I said, you see there's stuff that you get that you don't necessarily get if it's just an anonymous user.
Yeah. It's a complex topic to see if we can have the same user, because especially with the 5 most used routes, we focused on the ones that our competitor basically brought forward and is also measuring to have a real clear focus also on the same thing in reality. But this makes it a little bit more complex with having a user that is allowed to do that stuff. Good. Another really interesting thing is again here the LCP, the film strip, which also shows you exactly the markings again and what happened in each individual step. And for example, one of the things with the issue detail page is why it's measuring so long is that it doesn't get straight away that we are already doing like real-time updates. Even perhaps we are doing them way too early because we started sometimes the real-time updates before everything was already loaded, which also means that we are doing a lot of calls already. And this means that the recording is thinking, hey, there's still something loading, and doesn't say earlier, it's basically fully loaded. Then you have the coach, which is also a really interesting thing, but keep in mind that those are also recommendations, especially around classic website monitoring. So there are things that are totally true, like uncompressed size is 2.6 megabytes, and this is totally crazy. The coach is very right, but there are also some things that we need to do, like private cache headers due to security things, etc. But it can give you also a good insight, especially around what you could save with better images and things like that. Page X-ray, also interesting to really figure out if you have huge content, which is definitely a huge difference between cached and non-cached, because in the cached world, a lot of those impacts that you would have with that loading, a lot of those things like our icons, etc., they are already in cache and don't have that type of impact anymore. You see also the cache headers, which is an important thing, because there we also had some things that we requested in reality every call and needed to do some more setup around it. CPU, also very interesting, because you can really download a trace log and load it in your Chrome DevTools to see really the different timings of the different steps that happen. Third part is really a website thing, how much we load stuff from other domains. Lighthouse, and that is also really interesting, because Lighthouse is a performance tool that you also have in your Chrome. This is an additional monitoring. This is really already targeted. That's what I mentioned with the whole trend of doing rather mobile than desktop. This is already much more to having everything mobile first, but it can give you also a lot of insights, and especially insights around stuff that we can improve, and also figure out what we could save. So for example, reduce JavaScript execution time is a huge thing, but always remember that this is really like fully limited to completely a very slow CPU, but remove unused JavaScript, for example. So this is basically telling us what in our packages that we have actually loaded was never touched by execution. So this showed us, for example, a couple of weeks ago, still a lot of high numbers, what we could save on the main JavaScript bundle that was still then, I think 1.1 megabyte is now at 600 kilobytes. And we hopefully get this even lower in the near future. The biggest step in there, jQuery. And jQuery is something that you can't remove that easily, because it all the old bootstrap stuff, everything that we still have from older days in there is directly connected to it. But I really hope that we are able in the next months to at least take it out of the main bundle, so that we only load it for the very specific pages where we have like a very old school jQuery thing that we are still loading. Good. One more thing that I just discovered a couple of weeks ago is what you also have in here is the waterfall. And if you click here on the compare button, then you are able to upload 2 HAR files, and that gives you then a really nice comparison between all the numbers of those runs. So you can see, for example, if the numbers went up or down, what actually improved in the whole waterfall, in the whole setup. And something, for example, for the backend engineers, as I also just tested this last week, is we have also all the request and response data, which is especially interesting because we have in here, we also have here the X request ID, which gives us the possibility to go into our log files and really take a look at that specific call. And we also have the X runtime, which is, I believe, the time we spend in our Rails part. So this can give you also a much better insight, and we can basically follow up, especially if we have high time to first bytes, etc. So this is definitely not just something for front-end engineers, but is rather something for front-end and back-end engineers, as we also see all the different query calls on the API, etc. And we were able to see a couple of things that we improved over time. Good, let me take a look at my notes. LCP of the issue page by almost 50%. This is a perfect example that is a report from a couple of weeks ago from September 11th. And what you have here is that we there had still very high LCP. So we had an LCP, a largest contentful paint, of 6.3 seconds. And this was weird because if you look at the video, what you see here, if you slow it down, is that in reality, and we check this through Chrome DevTools, you can basically check what was measured as the largest element. And we even have added to our performance bar more measurements to see better and debug better what was measured in the different steps as the largest contentful element. And what you see here is that at 2.9 seconds, we already have exactly that DOM element on screen. So the question was now, why are we recording 6-point-something seconds, but in reality, everything that you should see or that is measured in the end is already at 3 seconds, which is half of it. And I'm not sure if you can still see it in this video, but there was 2 weeks before that, we were seeing really during the video like a big flash in between. But this gave us the hint to research in more detail what was going on in the issue detail page. And the thing, what happened here is that we had the stuff, the data that was coming in from the backend, from the initial page rendering, was sent through our DOM Purify library, and the API response wasn't. So to the user, it looked 100% the same, but in the background, it was a completely different HTML structure. So it had all the attributes were in a different order, etc. So this meant really to the browser, hey, look, I have new content, I'm rendering again. And that's what really happened, is that the browser rendered at 6 seconds when the first time the real-time changes came in. It said, hey, this is different because the HTML looks different compared to the actual content. And that's when where we went in, we changed simply that both get cleaned by the same function and problem solved, and our basically the LCP dropped and no more updates were done. And we also moved out the real start of the real-time changes to reduce the cost on the CPU, especially during that first rendering and start time. And that's where exactly this video was super helpful on figuring out where are those measurements coming from. Good. Questions? Anyone? No. So
just
that's the classic.
Sorry. Just a comment on the waterfall thing. Like we noticed the opposite problem for the what do you call it, the roadmap page. The request timed out basically in 10 seconds because the request was so slow to load that nothing on the page changed for 10 seconds. Request timed out. But the request itself actually takes 30 seconds. So like basically, even if we reduced the request time there by 50%, we would see nothing on Sitespeed, right? Because that times out after 10 seconds. So it's just something to be aware of. For that endpoint, we're using Kibana and some other Grafana charts instead to kind of measure our progress with reducing the amount of time that takes. We found some like N+1s and look aheads that we could do in the GraphQL. But just something to be aware of with Sitespeed. Sitespeed's great, but it nearly caught us out on this one.
Sorry for not muting myself and creating a huge echo for everyone. Yeah, totally. I think a good example is, and I really hope and I believe that we are moving into that direction, is in the next quarter is really, right now we are super focused on the most used routes, which is 5, which is the project home, issue detail, issue list, merge detail, merge list. But there are way more pages, of course, and way more routes that we are actually monitoring. And what we are currently focusing on is that the target is really 2.5 seconds is to have, that's the definition of a good LCP. And if you take a look at all our routes that we are currently monitoring, you will see that currently until here, we are still in the good area, and then it gets, so I would say 54%, if my calculation there on the Grafana dashboard is right. We have good LCP, but that means that the other 46% are not in that area. And we are most probably going to focus that we really get everything else also on the good side of the whole thing. And as you mentioned, you can have, especially, what was it, the milestone page and pipeline charts, they already have exactly that route has already like a time to first byte of 16.2 seconds, which means before you can see the first thing on screen, already 17 seconds are over. That is like almost 200-meter runs. That's a long time. So there we need to come in and also figure out what type of data we don't want to load on the first run, and figure out how we can split it up. And there are a lot of techniques that you can do to reduce page load, the overall load. Right now, the overall focus, and that's what I mentioned also in my how you can help, is each of those routes has like mainly global topics, which is really the stuff that we want to clear out, is the page specific CSS. That is something where people can jump in and their teams can jump in, and remove font awesome icons. This sounds super trivial. It is to some extent also quite easy to simply go in, replace an icon, get the icon out. We are getting closer to, I think, 280 or so instances that we still have left in the product. Why is this important for performance? Quite easy. As soon as we have cleared out all font awesome icons, we can delete this font, which means that most probably will save around 100 to 200 milliseconds. And that is definitely something where it's an easy task. It's simply a lot that we need to do, but at some point, hopefully it will pay off. And I already gave Martin, who is the DRI, he will be the one that is deleting the font awesome, and a lot of people will watch while he's basically while we are merging this. So that's definitely a topic. John, you are adding something.
Yeah, sorry, it's not quite global, but pretty close. Anytime you have GraphQL queries at the minute, as long as you're not working with fragments, you can use this. Well, you can't yet, but it will be merged fairly shortly, I think. You can use this helper to embed the GraphQL request in the page. And if you follow the rest of that MR, you can hopefully pretty easily use Startupjs for GraphQL queries. But like I said, we haven't merged it yet, but it's pretty close, and we're expecting like 20-25% speed increase from this. So like, yeah, just to put it on everyone's radar, I don't think the MR is going to change that much, so it's a pretty good precedent.
Yeah, thanks a lot, John. And I'm really looking forward to have this, because this can give us another nice boost, especially in the project homepage. Just to summarize what we are doing there, we have already a system. I didn't have any better name for it, so I called it Startupjs, which is a super magical way of simply doing something earlier than you would normally do. We have on the backend this time to first byte, which is, let's say, 500 milliseconds. And now, as said, we have 1.1 second of front-end global stuff that we are doing. So CSS, JavaScript, loading everything else, and getting ready, getting something on the screen that is meaningful. And now what happens is that if you combine those, you are already at 1.6 seconds. And most of the time, only then the actual JavaScript or view application or whatever you're doing on the front-end side, that is making us able to do async things, is only starting then. So then the application is started. Then we start, okay, hello view application, I need to go out and load some API endpoints. So let's call this endpoint, and let's call this endpoint. And then the endpoint is called, and then this endpoint takes 900 milliseconds. And suddenly already at 2.5 seconds, until you have all data available that you want to render on the first thing on screen, which is way too long. So the idea was quite simple, is to move exactly that call that we are doing then at 1.6 seconds and have it through vanilla JavaScript right after the server is loaded. So it's like a classic vanilla JavaScript that goes ahead and does the fetch from the API. And later, when the application starts and loads, the application goes out and says, hey, was there anything for me in the post box that was already, has this URL already been called? Ah, great, perfect. I just take the result, parse this, and then you have saved these 900 milliseconds that you would have needed to wait, and basically parallelize this with all the global front-end blah. And that's what Startupjs is. And what John and Natalia were working on especially, and I'm really looking forward to that, is doing the same thing for GraphQL, so that we can do GraphQL calls. You have a raise helper, you add it to your template, you say, please go ahead and call that stuff for me already. And then the application can basically pick it up from there and can take it and has already the data available when the application is started. And that is definitely a big help. And as it now sounds a little bit that we are taking very long on the front end side, yes, we are taking a very long on the front end. We need to reduce this. But as John said, there are a lot of pages that already take 9 seconds or 15 seconds to load at the moment. And that's where we need to get that stuff out of it to be basically faster and do stuff async, reduce the amount of data that we load at the beginning, or reduce the heavy lifts at the beginning, and then take it from there. Any other questions?
I'll just address Sam's point there. Yeah, I should have been clearer on that. Sorry. I'm not saying don't use fragments. We haven't found a way to support them yet with this. Like, because the tricky part is the query that's embedded in the page has to be identical, including white space, to the one that's issued through Vue.js. If they're not identical, they won't be hashed in the same way. So we'll create a cache miss, basically. And the request will actually be made twice. So we just have to figure out a way to consistently compose the queries on the front and back end. And it was just kind of out of scope for the first iteration, just try and get this proof of concept out and just see what it could do on one endpoint first. And then we'll try and, if it's successful, then we'll build it out for fragments as well.
Iteration for the win. Awesome. Good. Then let's
Tim,
try. Yes.
it might be worth talking, since we have several people on the call, about the potential issues of startup CSS that some people might be running into weird race conditions about what GitLab loads first. So I'll add a link to the auto size, how we work around the auto size to the document. So the question is, the startup CSS can change the order of things loading up. If the JavaScript is waiting for DOM to be there, it might not be there. So we devised a helper to make code wait for the CSS to be available, whatever comes first. So I'm just going to put here, workarounds. Anyway, I'll just type. You can go on, unless anybody has any questions.
Perfect. Thanks for bringing it up. Yeah, that might be that we run into some more race conditions. And just to clarify, startup CSS is, because naming is hard again, we picked up startup and called it the injection of critical CSS into each page through inline CSS. What does this mean? We have a crawler that takes a look at the page and takes a look what is actually necessary for everything on the top menu border and on the top navigation and on the left side menu. So all the CSS that is needed to render that stuff one-to-one in the same way as you see it at the later point. Because as said, we have huge CSS, so until this whole thing is loaded, until we have reduced this will take a while. So what we are doing right now is we extract the minimal CSS, which is 29 kilobytes or so, and inject it right into a style attribute. And this helps that the browser basically can go ahead and say, oh, there's my backend page. Perfect, I already have CSS. Boom, I render it to the screen. So before it was around one second before the first, or up to 1.5 seconds until anything on the screen happened. And now we basically get the backend and have 100 to 200 milliseconds later already straight away the first thing painted, which is not the thing the user actually has clicked, but you actually see the navigation bar in the left side menu, and that is much better than any white screen in that sense. So or looking at something, and that helps, of course, also the overall perceived performance. Good. Has anyone brought their own route? It's always hard to start new chapters or topics or ideas. So no one has brought an own route. Then I will magically take one out of my head, and basically let's take a look. Let's take something from the middle. Perfect. We are back in screen sharing mode. So what do we have here? We have, do we want to take a look at a new snippet editor? That sounds promising. Or verified job list, you choose.
My vote's for Snippet.
You vote for Snippet, I would have guessed so. Cool. Then let's take a look. So I'm taking a look at, that is a run that was from today. So let's look for that page. Where is it? Editor snippets. Why is it not there? Maybe that was something that was recorded in the past, but it's not recorded. But if we are already here, then let's say simply the explore. Let's take a look at that one. That has an LCP from 1.8. That's too easy. Yeah, that looks better. Editor snippets textual. So please chip in if you see anything, but I will simply go ahead now for the first time, and I hope that next time someone else does it, to go in and take a little bit of a look at how I would try to basically take it from Sitespeed and analyze it, then not only Sitespeed, but also then in the Chrome DevTools, etc., to figure out what are things that we could improve, what are perhaps low-hanging fruits, what is JavaScript that we have included that is way too big, and simply give a little bit more insight, but hopefully do this as a team. So let's take a look. We have an LCP of 4.392. Let's do the same check as we did with the issue page, which was figure out what we are doing there. So it looks like we have already something on the screen at 2.3 seconds. And then for a long time, nothing happens. Then we have a loading at the top. And then we have finally the actual stuff at 4.533, which is interesting because the LCP, yeah, is 4392. So that's quite aligned with what we also see on the screen, because we only see it really, there's no hidden thing in there. But what was also quite obvious is that we have in reality the application already at 4.1 seconds. So let's take a look at the waterfall, which simply means, and that's where now the overall thing from John can come in handy, is that we are doing the GraphQL calls back here. So you were, if you looked at the video, you saw already that the JavaScript application was already ready, but only then started really loading. And if we would move the GraphQL calls that we have in this line, and this line, and in this line, which is nothing is longer, there we even have a subsequential call. So that is also something we should be able to figure out, because it looks like that we need the results from the first one before we can actually call the second one. And why do we have on top of that 3 if it's GraphQL, if we could combine those? But the overall topic is nothing is longer than a second or anything. So this means that we have 200, the highest is 369. So if we move everything to Startupjs with GraphQL, we would be able to call it here, and it would be already loaded down here at the 1 second mark, most probably. So this means that as soon as we get the stuff loaded and activated, we should already have the data and be able to move the largest contentful paint in reality rather more to the onload, most probably, which will be a reduction of a second. Good, then let's take another look. Why are we talking that long for a lot of the JavaScript stuff? Okay, we have Monaco. I will take a look at the page X-ray. So we have, that is Monaco. Monaco is the editor that we are using. So this is not a big of a topic if we are talking about a cached application. So as soon as we have a setup that is more realistic with the user experience, we shouldn't be running that much of a problem into having such long loading times like this one. So that took 2 seconds to load in these setups, to 1 second. I think to some extent this is most probably also due to the extent that we are loading a couple of things, and it makes it harder for the CPU to digest. But overall, what do we have here? Total transfer, total content size is 6 megabytes. JavaScript is 1 megabyte. That's not, that's bad, but not super bad, especially as we have Monaco, which is a huge editor included.
Sorry to jump in here. Did that page actually need that editor, or did it just display the file?
This needs the editor, but in the sense that it needs to have the same rendering. It needs to be Monaco because we are doing the file parsing also based on the editor, because that is really now was a huge topic to reduce the number of editors. We have the web IDE, we have the single file editor, and moving that stuff across. But what with the snippets, we need to load it directly, because this is also another big topic, is that bundle splitting, which we are doing way too less, which is really like loading parts of the JavaScript only when you need it. So one thing, to give you a good example, is we were able to cut 80 to 100 kilobytes out of the main JavaScript bundle, simple by loading everything around the search bar that you see at the top, the search block, only when someone is clicking into it. So only if you click into it or you call the shortcut, then we basically go ahead and load the actual search JavaScript that we have in our main bundle. And this timing, especially if you have it cached, takes 4 milliseconds. This is nothing that you will ever see. So doing good web bundle splitting based on what the user will, you are trying to thrive really for everything that the user needs right away, and then you can still go in. There are tons of, you can load automatically, you can only load on interaction, but I think this is a huge topic I've seen. We have only 12 to 15 bundle splits in our whole code base, which is nothing compared to the overall code base. So really loading stuff that is only needed then would be super vital to reduce the number of the size of JavaScript. And that is especially important because a kilobyte of JavaScript is way more heavy and intensive to the browser than any image or anything, because it needs to parse it, it needs to get it ready, it needs to get it into the runtime, etc., etc. So every kilobyte counts to some extent, and hopefully our main bundle is anyhow so small soon that we don't need to figure it out anymore. Good. Let's take a look at Lighthouse. Not the best number, 25. It goes from 0 to 100, by the way. Let's see. We have here a counted largest contentful paint of 9.9 seconds. We have exactly that's where bundle splitting comes into play. We are using how much? 3 seconds we could save, most probably based on the stuff that we split out. So if you look at this Monaco, we could perhaps split out some languages. There's a huge chunk that is 223 kilobytes, and we could save 120, which is almost half, more than half of it. So this means that if we split it out, 50% of that stuff is gone and is only loaded on that interaction. And I've seen a lot of times already over the last weeks that we are loading stuff that perhaps 0.0003% of the people will actually click. So one of the best examples in that area is on the project homepage. Currently, we render still on the Rails side a modal for custom notification settings. I didn't even know until that point that we have custom notification settings, but this means that we are doing a query in the backend to figure out what are the settings of the user. We are initializing this on the JavaScript side. We are rendering this to the DOM. We have additional DOM elements. This is a huge pile of something that most probably, yeah, as said, a very small percentage will actually interact with. And if we are able to split it out so that you have in reality one button that says click on it, and only then we load the whole thing behind it, we have made a good saving on that. Any questions, ideas around the topic? As we are running out of time, I'm asking for one more round of questions. If nothing, then I would say thanks for joining, everyone, and I would love to hear your feedback. I know I talked a lot, and I would like to basically transition this hopefully over a short time also to others and see other people. I already asked for next week's performance bar session, in 2 weeks the performance bar session, that others will take that over and then really move it forward. And in the meantime, pick some icons, pick some CSS, get them out of the systems, and with each of those we have a huge help. And apart from that, thanks a lot for joining. Thanks a lot for the questions asked, and see you everyone in another call.